Okay, so we looked at a field that drops off as 1 over r, and we found that there must be some charge spread out away from r equals 0 in order to accomplish that, to make the field drop off less rapidly. Then we looked again at our 1 over r squared, the field of a point particle, where all the charges is at the origin, or r equals 0. Let's think about what we would get if we made it drop off even more rapidly. Right, so this would require something, in a sense, that involves charge that is less, in a sense, at the origin. It's basically going to turn out that we're going to be looking at a sink as opposed to a source of charge to make it drop off that rapidly. So the divergence will no longer be positive, something like that. So let's look at this. So let's say we have an electric field. E is some constant B. R hat, it drops off as r cubed. And let's see what we get for the charge density. So rho is equal to epsilon naught divergence of the field, which in this case is epsilon naught over r squared d by dr, r squared er, which is epsilon naught over r squared d by dr of, it's b over r, right? Because we have a 1 over r cubed. And of course, that derivative of 1 over r is negative. So in fact, we have a negative divergence. So we have minus epsilon naught over r to the 4th times b. So the only way to accomplish that is to create a negative charge density. Right, the divergence of the electric field is negative. So if we want to, well, let's think about how much charge we have in some sphere. So the amount of charge in that sphere is, well, we can do it obviously in two ways. We can do that calculation, which involves minus epsilon naught b integral of r squared over r to the 4th in dr solid angle integral, which gives us minus 4 pi epsilon naught b integral of dr over r squared, which gives us 4 pi epsilon naught b over r. Well, a sphere of whatever the radius of the sphere is, that's the amount of charge. Of course, it's the same thing if we do q is equal to epsilon naught integral of e dot dA. Arguably, that's easier. Epsilon naught, that becomes e times a, which is epsilon naught b over r. Well, let's make this 0 to capital R, so this becomes capital R. So this is b over r, cubed, times the area of the sphere, 4 pi r squared, and that is the same thing as before, 4 pi epsilon naught b over r. And so we see that the larger the sphere is, the less charge we have, right? So that's a very strange kind of thing. This isn't really a field produced by positively charged particles at some location, right? Because the field would die off as 1 over r squared. And so we notice something strange about this kind of supposed electric field.